Okay, for number 5, I'm going to go to the whiteboard again, and then we'll walk through the problem. And it shows the ranges between 1/3 and 3, all right? So let me just see if I can go to the whiteboard. And let me just get a pen out, all right? So what are we told over here? F of x is equal to x squared minus x plus 1. The bottom is x squared plus x plus 1. And we need to show the range for this particular problem over here is between 1/3 and 3. Now what does it mean? It means that the function x squared minus x plus 1 must be less than or equal to 3 for all x, by the way. This is in the domain of the problem to 1/3. So let's talk about the domain of the problem now. And what I notice about this over here at the bottom is never 0. Right, so its domain is all real numbers. Now, if you need help with that, what do? Is you just simply say, does it ever equal 0? You could write that down. And you could write the quadratic formula down for that because it doesn't factor using integers or rational numbers, I should say. So it's going to be 2 in the bottom. Then you get, a minus 1 plus or minus, b squared would be 1, minus 4ac, which would be 4. The discriminant's negative, so this thing's always going to be positive. Right, so I'm pretty clear that I know the numbers 1/3, between 1/3 and 3 are certainly positive. All right, and this actually helps me. All right, let me get rid of this over here. I'm get my eraser out. Get rid of this over here, and let me go back with my pen and paper. Now, since this x squared plus x plus 1 is positive, I can multiply all 3 sides of the inequality by that. And what do you get? You would get x squared plus x plus 1 over 3. Then you get x squared minus x plus 1. And over here you get 3 times x squared plus x plus 1. All right, I still don't like the fraction. I multiply all sides by 3 now. And you get x squared plus x plus 1. This would be 3x squared minus 3x plus 3. Again, I'm multiplying by 3. You get 9. Then you get x squared plus x plus 1. This is pretty nasty. Let's keep going. And what do you get over here? X squared plus x plus 1. 3x squared minus 3x plus 3. This would be 9x squared plus 9x plus 9. All right, I got 2 inequalities to deal with now. Let's write one at a time down. So I get x squared plus x plus 1. 3x squared minus 3x plus 3. The other one's an and, by the way. And it must fit this condition too, which is 3x squared minus 3x plus 3 less than or equal to 9x squared plus 9x plus 9. Let's do one at a time. So what do you get over here? It's going to be 2x squared. I subtracted x squared from both sides. I'm going to subtract x from both sides. That's minus 4x. And I'm going to subtract 1 from both sides, and that will be plus 2 equals 0. Let me keep doing this. You get 0. Then you get 2. I'm sorry, I'm dividing by 2. What do you get? 0, x squared minus 2x plus 1. All right, let's look at that. I think I can do that. So you get 0. And what's this going to be? X minus 1 squared. Let me just check that. You do get x squared. You do get minus 2x plus 1, yeah. So what's the solution to this inequality over here? It's all real numbers. Every number in the universe is going to fit that. So the solution is minus infinity to infinity, which is good news, by the way, because I want it to be minus infinity to infinity. Why is that? That's the domain of the problem. I want that to be true for that. Let's do the other one, see what happens over there. And you get, let's see, I'm going to say 0. I can subtract 3x squared from both sides. You get 6x squared. By the way, we're doing it in amps. We get an intersection of the 2 sets, by the way. Then you get 12x plus 6. Let's see if I did okay there. Let's see, 6x squared, 12x, and a 6. I'm going to divide by 6. X squared plus 2x plus 1. And my question is, what's that guy? And it's going to be 0, and that's going to be x plus 1 squared. And by the way, this is also true for all real numbers. Where do those two sets intersect? Between minus infinity to infinity. So this thing here, as we've shown, the solution to this over here is minus infinity to infinity. What have I just shown? On the interval between minus infinity to infinity, this thing is bounded by those two numbers. And we're done. Thank you.